Okay, welcome to 1-3, Measuring and Constructing Angles. First things first, if you notice, we got some math humor. So question, what do you call people who are in favor of tractors?
Protractors.
They don't get any better than that. All right, you guys, we're going to start with a warm-up. I'm going to have you guys do numbers 1, 2, and 3. So you're going to pause me, and then when you come back, we'll go through our answers together. All right, you guys, so for number 1, they want to find the midpoint between T and W. They give you the length of T, the point T is 2.7. The point W is 8.1. Remember, to find the midpoint between 2 points, you do the average. So you're going to add the 2 together, divide by 2. So your midpoint should be 5.4. In number 2, a picture would have helped you. If you draw the segment EQ and put in K, which is at the midpoint, you should see that EK is congruent to QK. And in number 3, if S is your midpoint, that makes these two segments, RS and ST, congruent. So you would set them equal. If they're congruent, their measures are equal. Set them equal, and you come up with X is 6. But they want to know the length of RT. So once you simply plug that in, you'll get RT is 28. All right, you guys, this stuff is review. Review. The very first day of notes we did this. Ray, remember, is simply a part of a line. It consists of an endpoint, and then all other points on one side. Continues forever in one direction. Remember, opposite rays are two rays that are connected with the same endpoint, but going in opposite directions. All right, something new, you guys. We're going to talk about angles now. Angle, or an angle, I should say, is simply a figure that's formed by two non-collinear rays with the same endpoint. Okay? So remember, opposite rays were two rays that end up going in opposite directions, but they ended up forming a line. These are non-collinear, meaning you cannot form a line here, unless, of course, we have a straight angle. We'll get to that later, though. The rays themselves are called the sides of the angles, so rays are the sides of the angle. The common endpoint, so where they meet, is called your vertex. The set of points between the sides of the angle is the interior of the angle, so everything in here is in the interior. And anything on the outside, out here, is called your exterior, or the exterior part of your angle. All right, so we're going to use the same angle as we had on the previous slide. We're going to name some things. First of all, let's name the sides. If you remember, the sides are actually the two rays that form the angle. Hopefully, you can see that the two rays that form the angle are ray DV and ray DR. The vertex of the angle is where these two rays are actually connected, the common endpoint. And if you notice, your common endpoint here, the thing that holds these two rays together, is D. Name the angle in 4 different ways. You could name the angle simply with that vertex. You could name it angle D. You could also name it if it has a number inside of the angle. So this could be angle 2. Or you could name it the old-fashioned way. Use the 3 points, one on each of the rays, and then your vertex has to go in the middle. So we could name this angle VDR. Or you could go the other way and name it, angle RDV. Do not forget, an angle is measured in units called degrees.
Now we're going to take a look at the different types of angles that are possible. And I know this is just a review of what you've learned in your previous math classes, so this should go kind of quickly. The first type of angle we're going to talk about is a right angle. And that right angle is an angle that has a measure of 90 degrees, exactly 90 degrees. So when we draw this angle out, to the best of my abilities, that's pretty darn good. That angle is a right angle. We know it's a right angle because we're going to label it using this little box. Anytime you see a little box like that in the corner of an angle by the vertex, it means that this is a right angle. It is 90 degrees exactly. Now what happens if I have some angle that has a measure that sits between 0 and 90? We call that an acute angle. An acute angle has a measure between 0 and 90, so it has to be less than 90 degrees, but more than 0 degrees. So an example of that would be an angle that looks like this, okay? So maybe, for example, I would say that this angle has 42 degrees. That means that is an acute angle, because it's a cute little angle, okay? The next type of angle is an obtuse angle. Now, that obtuse angle has to have a degree measure that sits between 90 and 180 degrees. So it's going to sit somewhere a little bit over 90 degrees, but not so much that it's making a straight line. So, for example, what if I give you an angle like this, and I said, oh, okay, it's going to be, say, 110 degrees. Okay, so that's an obtuse angle. So the way I remember the difference between an acute angle and an obtuse angle is an acute angle is a cute little angle, and an obtuse angle is huge. So it's bigger than 90 degrees. The last angle that we're going to talk about, the type, is a straight angle. And a straight angle is an angle that has a measure of exactly 180 degrees. And that is actually just a straight line. So there we go. That's an example of a straight angle. Lastly, congruent angles are angles that have the same exact measure. Just like congruent segments have the same measurement, angles can have the same measurements. So I'm going to draw two angles here, and hopefully they look exactly the same. And we're going to label them with, let's say, 40 degrees. And the way in which I know angles are congruent is with this little arc. Anytime you see a little arc inside of the angles, that means that those two angles are indeed congruent. So they have the same exact measure. So what happens when we give an example and we give you a protractor? I'm going to ask you to find out what the measure of each of the following angles is. And then what you're going to do is you're going to classify that angle as either acute, right, or obtuse using the definitions we just talked about. So the first example is angle DOA. So we're going to figure out, oh, well, there's point D. We're going to go to O, and we're going to go to A. So we're talking about this angle right here. Now that I've drawn all over it. If I'm taking a look at that angle, we need to figure out what the measurement is. Now, first off, you should ask yourself, is this angle an obtuse angle or is it an acute angle? It looks to me as though this is an obtuse angle. Therefore, the measurement should be between 90 and 180 degrees. So if we take a look at where this is situated, angle DOA, it sits somewhere around here. Now, it either looks like it would be a 55-degree angle or it looks like it would be a 125-degree angle. Since it is an obtuse angle, we're going to go with 125. So we're going to write down 125 degrees, and we already talked about it. It is an obtuse angle. So do me a favor, try to figure out the next two. Come back, pause the video, come back, and we'll take a look at the answers. So let's take a look at your answers. Hopefully for B, angle BOA, you ended up getting 35 degrees. If you trace that out, it was an acute angle, small little angle. So therefore we used the measurement between 30 and 40, which was 35. For C, angle COB, the measurement of that angle, COB, that's a little weird. How did we end up getting 75? Well, if we take a look at this, we're going to start off here. It's 35 degrees, and if we track the interior numbers, it goes all the way up to 110. So the difference between 35 and 110 is 75 degrees. Therefore, angle COB is 75 degrees. That means it is an acute angle.
All right, so just as we did before, we were talking about the segment addition postulate. I told you this isn't going away. We're going to keep adding to it. We're going to do another addition postulate, but since we're talking about angles, it's only right to talk about the angle addition postulate. So they're telling you that if R, right here, is in the interior of this angle PQS, what happens is you have PQR plus RQS equaling PQS. Again, you guys, this is the part plus part equaling the whole thing. All right, so there's going to be some scenarios where we're just going to simply ask you to write out the angle addition postulate. That is what we're asking for right here. I want to know what angle plus what angle equals what angle. So first part simply is just angle RDT. So we have the measure of angle RDT. And if we add it to the measure of angle TDN, it should give us the measure of angle RDN. part plus part equals whole. All right, the next example asks you to write out the equation first for the following, and then they want you to solve. So they give you a picture, they give you some information. The only logical thing to do is probably to fill in your picture first, come up with an equation which will help you solve. So they say RWT is 2x, and if you look, RWT is right here, so this is going to be 2x. Sorry, you guys, I'm getting better. Then they say TWK is 5x minus 20. And RWK, that's all of that, is 4x plus 40. Well, what do you know? They give you a part, they give you the whole thing. I want you to set up the equation, and I would like for you to solve. So pause it, set it up, solve it, and then we're going to come back and see if we end up with the same thing. All right, you guys, after doing your wonderful algebra, setting it up, part plus part equals whole, you should have gotten that x is 20. Okay? If x is 20, therefore, if we go back, it says to find measure of angle RWK. Well, the measure of angle RWK is supposed to be 4x plus 40. So if I plug in my x, 4 times 20 plus 40, we get 80 plus 40, which is 120 degrees.
So another definition that we want to take a look at is an angle bisector. And an angle bisector is a ray that divides an angle into two congruent angles. So if I draw out an angle, and with this angle, I'm going to throw in a ray. And this ray, hopefully by my drawing, doesn't suck too bad, ends up splitting that angle into two congruent parts. And we know it splits it into two congruent parts because I used the arcs there. Then that says that this ray right here is an angle bisector. So if I put some letters down with it, A, B, C was my angle, and we're going to say this is D, we would consider ray BD to bisect my angle ABC. An angle bisector also, if you think about it, it's kind of like a midpoint, but with angles. So a midpoint constructs two congruent segments, and an angle bisector constructs two congruent angles. So for this example, we're going to go ahead and name the two congruent angles that are formed by each angle bisector. So hopefully you notice we've got ray GX on the first one, trying to make a ray out of that one. And it's bisecting angle DGK. I'll do the first one with you, and then I'll have you do the second one by yourself. For the first one, the easiest way that I do this is I draw out a diagram. So what we're going to do is we're going to draw out the angle DGK, and we're going to put then our ray GX on the inside. And it said that that ray actually bisected the angle, so I know those two angles are congruent. It makes it a lot easier for me to be able to see that this angle then, DGX, is now congruent to angle XGK. So that's what we're going to write down as our two congruent angles. So once you've got that written down, go ahead, pause the video, and do the next one. We'll see if we get the same answer. So for the second example, hopefully you ended up getting that angle AMQ is congruent to angle QMV. The third example we have on this is one which we give you that ND is bisecting angle ANP. So if ND is bisecting my angle ANP, what I'm going to do before I do anything else is I'm going to mark it off with two arcs. So I remember that they form two congruent angles. The next thing they say is angle AND has a measurement of 2x plus 15. So we're going to go ahead and label that on the inside. They also tell me that angle DNP is 5x minus 45. And then the last thing they say is find out what angle ANP is. They want us to figure out what the whole entire measurement is. Now my problem here is they did not give me anything signifying the whole entire measurement. So you're not going to be able to do part plus part equals whole. However, you were told that you have an angle bisector. Therefore, these two angles are congruent. We're going to go ahead and set them equal to each other. Now I'm going to set them equal to each other, so are you. And then you're going to solve it. You're going to figure out what x is, plug it in, and then try to figure out what the whole entire angle is. Go ahead, pause the video, come back, and we'll see if we have the same answers. So I ended up getting x equals 20, and if x equals 20, we're going to throw it back in. If I did 2x, so 2 times 20 plus 15, we're going to end up getting 55 for this angle here, which means that angle DNP is also 55. And if the two angles are 55 degrees, therefore, the measurement of angle ANP, the whole entire angle, would be the addition of those two, which is 110.
All right, last example, you guys. It says that the measure of angle AND is 4x, ANP is 10x minus 30. They want you to find DNP. So let's go ahead and label first, see what the heck they're talking about, and then we can kind of sort of figure this out. So AND, which is right here, is 4x. Okay, it says ANP, which is this right here, the whole thing, is 10x minus 30. And they want you to find DNP. So this is our mystery piece. Well, the cool thing about this is that they tell you that ND was actually your bisector. Remember, in the beginning, they said that this is the bisector. And if you remember, an angle bisector creates two congruent angles here. So if this is 4x, this is also 4x. Now, if you take a look, we have a part, we have a part, we have the whole thing. We can use this, excuse me, the angle addition postulate to help us solve for x and then find our angle. So, part plus part equals whole. We have 4x plus 4x equaling 10x minus 30. Go ahead and do your algebra and come up with x, please. All right, so you should have come up with x equaling 15. So if x is 15, now all I have to do is plug that in for DNP. DNP right here is being represented with a 4x. So the measure of angle DNP would actually be 4 times 15, which would give you 60 degrees. All right, that's all for this lesson, you guys. Do your whisk. We'll see you tomorrow and have a great night.